Today's lesson is 10.2. We're starting to look at the normal curve and creating a normal curve and interpreting a normal curve, given that we have a data set that does represent that shape. Make sure that you have this written down somewhere, or you have that sheet that I gave you on Friday. The empirical rule and the normal curve. We need to memorize these percentages. So make sure we have this, or we have this down, as this is what we're going to be using and I'm going to be referencing throughout the video. Last lesson we looked at histograms, being able to input the data into our calculator, create a histogram, and see its general shape, what it looks like. So getting a little bit more into that, if we create a histogram and we want to use this, we want to use it to see its general shape. So ideally, we're looking for something in this unit that is approximately normal, so that we can use our population percentages for the normal curve. So something that is approximately normal, as we kind of talked about previously, is it peaks in the middle. So our highest point's in the middle, and then we go lower as we go to our outside tails. However, things can be skewed, and if they're skewed, they could be left skewed or right skewed. And if they're skewed, that just means that it peaks off towards the left or to the right, and we have less information on half of our histogram. So what we are looking for is, if we were to have a data set and enter it into our calculator, we're looking for something that is approximately normal. So everything that we're doing from here on out only applies if something is of this shape, where it peaks in the middle and then our tails go to the outside where we have less data. So if something is approximately normal, we've got two things that are very helpful in helping us determine population percentages, and that's our mean and standard deviation. So mean, we've probably talked about, that's our average, our middle number of our data set. But a powerful measure of spread is how far apart all of our data is, and that's standard deviation. So standard deviation is how far apart all our data sets points are from each other, where the mean is our middle value. So we're going to be using mean and standard deviation to create our normal curve to use our population percentages. So like I said, if you don't have that sheet that I gave to you guys, or you have not written down, please make sure you get this written down. These percentages you will have to memorize. So this is our normal curve. It peaks up in the middle, and our tails go out to the left and the right, and in our tails we have less people falling in those ranges. So if we have a normal curve, most of our data falls right in the middle of our bell curve. Now 50% of the data is going to fall to the left of the mean, 50% of our data is going to fall to the right of the mean. So we can see that represented up here. So 50% goes to the left and 50% goes to the right. Now each of those halves are then broken down. So where we have these different colors, those are our different standard deviations. So right dead center we have our mean, and then one to the right is one standard deviation. This would be 2, and then 3 standard deviations. We have 1 standard deviation to the left, 2, and 3. Within 1 standard deviation to the left and to the right, we have 68% of our data in here. In this purple area here is 68% of people fall within 1 standard deviation of our mean, which means 34% are to the left and 34% are to the right. Then within 2 standard deviations, 95% of people are going to fall within 2 standard deviations. So here we have on the left side 34 plus 13.5, and we have that on the left as well. And then within 3 standard deviations, we have 99.7% of people falling within 3 standard deviations. And we leave that little room on the outside because we can always have those outliers that fall further than those 3 standard deviations. So have this written down. We're going to be using this moving forward. So example 1, it says the average height of American men is 69.1 inches with a standard deviation of 2.9 inches. Sketch a normal curve out of 3 standard deviations to both sides. So we're going to assume that this data set is normal that we're given here. So in the future, we may have to determine that by using a histogram. Here, we're going to assume that. So right here in the middle is going to be where our mean is. So I'd go ahead and sketch this bell curve. And then right in the middle is going to be our mean. And our mean is 69.1 inches. So right here we have 69.1. So now we want to use our standard deviation to go 3 standard deviations to the left and to the right. So if we're going to the right, we're going to add our standard deviation. If we're going to the left, we're going to subtract it. So if I want to go to 1 standard deviation above the mean, I'm going to add my standard deviation. So 69.1 plus 2.9 gives me 72. If I want to go to 2 standard deviations, I'm going to have to add 2.9 twice to the mean, or I'm adding 2.9 to 72, which is going to be 74.9. And then if I want to go to 3 standard deviations, I want to add an additional 2.9, which is going to give me 77.8. So 72 is 1 standard deviation above, 74.9 is 2 standard deviations above, and 77.8 inches is 3 standard deviations above. Now we also want to go below. So to get 1 standard deviation below the mean, I'm going to take 69.1 and subtract 2.9, my standard deviation. I'm going to get 66.2. To get 2 standard deviations to the left, I'm going to subtract another 2.9, which gives me 63.3. And then to get 3 standard deviations, I'm going to subtract another 2.9 to get 60.4. So this would be my normal curve with 3 standard deviations on both sides of the mean. So my mean is at 69.1, and then each increase or decrease by 2.9 is another standard deviation away. Now, based on our empirical rule that we saw, we can use these population percentages. So what that means is that on both sides of this is going to be 50% of the data. So here's going to be 50% of people are going to be on the left side and 50% are going to be on the right side. It also means that from here to here is going to be 68% of people. 68% of men are going to fall between 66.2 inches and 72 inches. And 34% will fall here, and 34% will fall here. And then we have the same thing with 2 standard deviations and 3. So from 63.3 to 74.9, we know that's 95%. So in here is 13.5% and 13.5. And then here we have our 2.35. So we can use these percentages by adding, subtracting to get different percentages of people between different standard deviations. So let's look at a couple examples. So now that we've created a normal curve for our data, we want to interpret it. So it says, what percent of men have a height more than 74.9 inches? So if we go to our normal curve and we find 74.9, it's right here, and we know that our mean is here, we want to know how many people, how many men have a height more than this. Well, if we think about what all of our percentages are, we have 34, 34, 13.5, 13.5, and then we have 2.35 and 2.35. Now, we know this whole side here is 50%. We know that this is 34 and this is 13.5. So if we add up everything to the left, we add up 50% plus 34% plus 13.5%. We know that 97.5% of the data is to the left of that red line. So that means, well, how much is to the right? If we take 100 minus 97.5, we get 2.5%. So 2.5% of people, of men, have a height of more than 79.4 inches. So I took everything over here, added it up, and subtracted from 100, and that told me how much was more, how much was over here, how many more men were there. So what percent of men have a height less than 72? So if I bring up, go purple, here I have 72. I want to know how many men have a height less than 72. Well, I know from this blue line over here, I have 50%, and here I have 34%. So if I add those together, I would have 84% of men have a height less than 72 inches. So what percent of men have a height between two of our standard deviations? So if I'm between 66.2 inches and 79.4, I'm here, 74.9 is what it should say. Between 74.9 and 66.2. So I'm between these two green lines here. So I want to know what percent is between. So if I add up those percents, I have 34 plus 34 plus 13.5. So I have 81.5% of the men fall between these two height ranges. Number 4 is a little bit different. It says if 1,200 men were surveyed, how many would you expect to have a height between 66.2 inches and 72 inches? So this is something how we can actually apply this data to something in the real world is, okay, we have a set of data, we've collected all this data, well, now we want to predict something. So we're going to use our data to predict that. So if I'm looking between 66.2 and 72, I'm looking between one standard deviation to the left and one standard deviation to the right. So that's all of this in here, from here to here. So that's 68%. So 68% of men fall between these two height ranges. Well, if I have 1,200 men, I want to know what's 68% of that. So I take 1,200 times 68%, 0.68, and that's going to give me how many men you would expect to have a height in that range, and that would be 816 men. So right now we're only playing around with these exact percentages that we have on here. So memorizing our 34 is one standard deviation away, 13.5 is additional percentage for 2, and then 2.3 we add on to get to 3 standard deviations away. And our entire bell curve is 100%. We've got 50% to the left of our mean and 50% to the right. So we're just focusing on using our mean to find 3 standard deviations and then working with these percentages. So here's one last example. I want you to try this one on your own. So in 2017, the mean SAT score was 1083 with a standard deviation of 194. So this is true data here. This data is normal, so we can go ahead and use our normal curve. So I'd like you to put your mean on your normal curve and go 3 standard deviations on both sides of your mean. Pause the video, write down your answers, and then play the video to double check. So here's what your normal curve should look like. We have 1083 as our mean right in the middle, and then we got our 3 standard deviations on each side. So check to make sure this is what you have and have this copied down in your notes. So now with our normal curve that we created, I want you to go ahead and interpret this with population percentages. So I want you to go ahead and answer these 5 questions. So get these 5 questions copied down in your notes, use your normal curve to try and answer these to the best of your ability, and then go back and play the video to get the answers. All right, so question 1, what score do 50% of students score less than? Well, 50% of students score less than the mean, so we would have 1083. What percentage of students scored less than 889? So if I find 889, there's kind of 2 ways I can do this. To be the most accurate, I want to add up everything to the right and subtract from 100, because I know that this is 50% over here. So I can take 50 plus 34 to give me 84, and I can subtract that from 100. So 100 minus 84 is going to give me 16%. So 16% of students score less than an 889. And I want to use the right side and subtract because I know 100% that this is 50. What I don't know is exactly what is here, because there's always some little bit that's beyond 3 standard deviations. So 16% here. What percentage of students score above an 889? Well, if 16% score less, I know that the other 84% score higher. Then I have what percent of students score between an 889 and a 1277. So I have 1277, I have 889. So between, I have 34 and 34, which is going to give me 68%. And last but not least, what percentage of students score between a 695 and a 1277? Well, I still have 1277 in the same spot, 1 standard deviation above, and 695 is 2 standard deviations below. So if I add up this area here, I have 34 plus 34 plus 13.5. So I have 68 plus 13.5, which is going to give me 81.5%. So overall, today's lesson, given a standard deviation and a mean, can you construct a normal curve given normal data set? Go in 3 standard deviations above, 3 below, and then interpreting this normal curve with these population percentages that we've been given.